Welcome to the Periodic Table, Tyler.
Thank you. It's nice to be back.
So today's pre-class video is about solutions chemistry. We're starting a new chapter on solutions. Many chemical reactions are done in solution. For example, my body is a series of biochemical reactions. That's what metabolism is. And it's all happening in aqueous solution. And so the first thing we have to do when learning about solutions is talk about a little bit of terminology.
Sure.
So what does it mean to be a solution? What is a solution?
A solution is... that's a good question. I think it's just something dissolved in something else. Okay, so it's when one thing called a solute is dissolved in another thing called a solvent. Okay.
Right? And so aqueous solutions are when you have something dissolved in water. But you can have a solid solution where you have, for example, a little bit of chromium metal dissolved in iron metal, right? It's all mixed together. As long as it's homogeneous and it's evenly mixed, that's considered a solution. That particular one is called an alloy or a solid solution. I'm breathing in a solution. It's a homogeneous mixture of nitrogen and oxygen and argon, a little carbon dioxide.
Methane if you farted.
A little methane, yeah, none in here. And so the first part of the activity is about learning about some terminology. The main part of the activity is about learning about concentration. And concentration is just a certain amount of something dissolved in a certain volume. So in the lab that you guys did, you worked with iron solutions where the concentration units you used were milligrams of iron, an amount, dissolved per liter of water, a volume. Now, what we normally use in chemistry isn't milligrams per liter. We have another funky unit for that.
It's called molarity.
Molarity.
Big M.
Capital M. What? Anyway. So I thought one of the things that we could do is maybe make a couple different solutions. And so we have some copper 2 chloride. And I'm going to make two solutions. I'm going to take a little bit and put it into this volume. And then I'm going to take a lot.
That is a lot.
And put it into this volume. Maybe I'll put even more in. And we swirl it around to get it to dissolve. And voila, we have the solutions. And the one I put a little bit in, it's only really lightly colored. The one that I put a lot in, pretty darkly colored, right? This is more concentrated. There's more stuff in the same volume. If I take a little bit out of this, put it in here, are these the same concentration?
Yes, right now they are.
Yeah, they're the same concentration. They're different amounts because I've only have a little bit in here. And I can dilute this. I can make it at lower concentration by taking this concentrated solution, just like you did in the lab, and adding more volume. And now I have another dilute solution. Right? And there are equations that you're going to use to calculate dilution factors. The last piece that I want to show you is if I take another compound, and I'm only going to take a little bit, right? I'm going to put a little bit in there, so it's not going to be very concentrated.
Wow.
Right? Wow. That's pretty intense. Purple, favorite color. So the fact that it's dark doesn't necessarily mean that it's concentrated. To compare color and concentration, you have to compare apples to apples, right? Over here, this is a huge amount that's dissolved, that's not very much. For this particular compound, this is not very much dissolved. If I tried to dissolve a large amount, it would look pretty much black. In fact, this is almost so dark you can't see through it.
Mm-hmm.
So, I think that gives you enough information to start the class. Good luck on solutions.